Good day, my highly esteemed viewers. You are welcome back to my channel. As you already know, my name is Israel Egwai. In today's video, we are going to be I'm going to be teaching you some reactions of organic compound. Notable among them is alkane. Alkane. Please, after watching this video, do press the like buttons. Also help to subscribe. Also subscribe because your subscription is actually what keeps our channel going and encourages us. Also help me to share this video. God bless you. So like we said, reactions of alkane. First of all, we know that alkanes are organic compounds which conform to a general molecular formula CnH2n plus 2, meaning they have the general molecular formula, all alkanes. They are saturated hydrocarbon. What do you mean by saturated hydrocarbon? It means they have single bond in their skeleton or their compound. For example, you can see these are single bond between two carbon atoms. It can be longer, it can be shorter, but they all have single bond. There is no single double bond or triple bond. So they are alkanes. But the topic of the day, as we have said it, is they are the reactions of alkanes. Alkanes being saturated hydrocarbon, that is single bond, they undergo just two types of reaction. The first one is combustion reaction and the second one is substitution reaction. First of all, what is combustion reaction? Combustion reaction is the presence of burning substance in oxygen, which we also refer to as fast oxidation. You react it with oxygen or you burn it in air. Burning it in oxygen means it's undergoing combustion. While substitution reaction simply means is a reaction which another element or group of elements take the place of another element or group in a compound. Let us get started with the reactions. We said the first one is combustion. Combustion reaction. So we are going to use methane because it's the simplest member of the series. But you already know, due to their all of them, all the alkanes undergo similar chemical reactions, although they vary in strength as the number of carbon atom increases based on what we learned under homologous series. So we are using the simplest member, CH4. CH4 simply means methane. This is the molecular formula for methane, CH4. If you react it with oxygen, it will give you, remember it's a hydrocarbon. We were told the other time that all hydrocarbon burn in oxygen to produce carbon dioxide and water. So we just write CO2 plus H2O. Remember, in your examination bodies, all your examination bodies, by the time you write carbon dioxide and water, they score you a mark. You have a mark. Usually there are 2 marks attached to it. We call the 2 marks are not tied. The first mark is on correct reactants and product, which is already written here. CH4 plus O2, CO2 plus H2O. Second mark is on the balancing. So let us see how the balancing looks like. So you have 1 carbon here and 1 carbon here. That is complete. You have 4 hydrogen. You have to include 2 here. 2 times 2 is 4. But if you look at it, we now alter oxygen. 2 oxygen, 2 oxygen. Therefore, you put 2 here. So you score the second mark. This is what they do in all the examination bodies. So this is combustion of alkane, notable among them, methane. React methane with oxygen to produce carbon dioxide and water, and this is the balancing. So let's have a look at the substitution reaction. We already also said, which is second reaction which alkanes undergo. So number 2, substitution reaction. Let's also use alkane. No, that's the number one they use. You can also use others. CH4 plus Cl2. You react alkane or that is methane with any of the halogens. You can use chlorine, you can use bromine, you can use iodine, you can use fluorine. Anyone that you prefer to use, you can use the same processes. However, in real life, they may not use all of them because some are very, very reactive, like fluorine is very reactive and always release a lot of heat. It's too reactive. The same thing applies to as it goes down, reactivity starts. All of them have their various ways they react. Therefore, we are going to use chlorine. That is not to say why I cannot give you equation involving fluorine. They can always give you. So let us use chlorine, Cl2, to give you CH3Cl plus HCl. You see it. So one thing you must notice this: the reaction, the condition is that they must be gaseous. That's the first condition. The second condition is that you must use light. Light must be present, UV. So these are the 2 conditions: presence of light and they must be gaseous. The reactant must be gaseous. So we now we call this one chloromethane. You continue, you have CH3Cl plus Cl2. We are trying, or we continue to react until we remove all the hydrogen atom. That's what makes it substitution reactions. So you have CH2Cl2 plus HCl. This dichloromethane. Then you react again, CH2Cl2 plus Cl2 to give you CHCl3 plus HCl, trichloromethane. Then lastly, CHCl3 plus Cl2 to give you CCl4 plus HCl, tetrachloromethane. So these are basically the 4 reactions which alkane undergo, methane can undergo. The first one is, the product of the first one was chloromethane, followed by dichloromethane, because you have two chlorine atoms or 1 chlorine molecule. Trichloromethane, tetrachloromethane. Remember, these are the various products. The 2 conditions once again is that they must be gaseous, the reactants, and light must be present. Note also that this third product, which is trichloromethane, usually previously called chloroform, is usually used by medical doctors as an anesthetic for minor surgical operation. So these are some of the reactions which alkanes undergo. Notable among them, combustion and substitution reaction. Those are the 2 notable reactions they undergo. Thank you for watching my video, but please, as I always appeal to you, kindly subscribe. God bless you.